Let's now proceed to lesson 3.4. Lesson 3.4 is solution by completing the square. If we are given this quadratic equation, ax squared plus bx plus c equals 0, a not equal to 0, and a, b, c is any element real, we can solve the solution set of this equation by employing the method we call completing the square. For this method, step 1 will be to isolate the constant term. The constant term here is c. Isolating the constant term means we will use addition property of equality to transfer that c to the other side. So we get here ax squared plus bx equals negative c. Step number 2. We want to make this coefficient of the squared term be equal to 1. So we are going to apply MPE by 1 over a, so that this becomes a 1. Use MPE by 1 over a in step 1. So therefore we get 1 over a ax squared plus bx equals negative c gives us now x squared plus b over ax equals negative c over a. Let's term this left hand side and this one right hand side of the equation. Step number 3, complete the square of the left hand side. Completing the square of the left hand side means we want to find the third term that will make the left hand side become a perfect square trinomial. And the formula for obtaining the third term is actually 1/2 the coefficient of the x or the linear term, and then you're going to square this. So it should only be the coefficient of x. So we have here now 1/2 of b over a, and then square this will give you b squared over 4a squared. b squared over 4a squared is the term that will make the left hand side become a perfect square trinomial. Having obtained this, we are going to add this term to this equation. X squared plus b over ax equals negative c over a, and we arrive at x squared plus b over ax plus b squared over 4a squared equals negative c over a plus b squared over 4a squared. We are allowed to do that because of addition property of equality. And step 5 allows us to express the left hand side as a square of a binomial, at the same time simplifying the right hand side. Simplifying the right hand side here means we're going to add the right hand side. Let me go back to this. When we solve for the third term, we were actually finding the third term that will make this binomial become a perfect square trinomial. And that term is b squared over 4a squared. Adding this term b squared over 4a squared to x squared plus b over ax assures us that the result here is a perfect square trinomial, which we can now write as the square root of x squared is x, and the square root of b squared over 4a squared is b over 2a squared. And simplifying the right hand side, LCD for a and for a squared will be 4a squared. 4a squared divided by a is 4a times negative c. I get here negative 4ac. And then 4a squared divided by 4a squared is 1 times b squared will give me b squared. We have now arrived at a form that is similar to what we have seen before. Something like this. Triangle squared equals p, and we were able to solve for this kind of equation either using extracting the roots or square root property, or using the absolute value definition. Which means for this equation here, we can now solve for x by either using method A and method B we discussed earlier. Let me show you how. I'm going to rewrite minus 4ac plus b squared as b squared minus 4ac. I'm allowed to do that because of commutativity. Okay, this is the form that we have had. I was saying, I can apply extracting roots now and I can get the value of x, or I can apply absolute value definition. Let's say we're going to have extracting roots here. I will just say this implies x plus b over 2a equals plus or minus square root of b squared minus 4ac all over 4a squared. And solving for x here, I'm going to use addition property, and this gets me negative b over 2a plus or minus. Note that this radical here can be written as square root of b squared minus 4ac over square root of 4a squared. The denominator is actually a perfect square, so I can have here a 2a, which leaves me with the numerator b squared minus 4ac. If I'm going to add these two fractions, the LCD is 2a, and I will get negative b plus or minus square root of b squared minus 4ac. This is now the solution to our equation ax squared plus bx plus c equals 0, where a is not equal to 0. We did the solution using completing the square. And when we arrived at this form, we used extracting roots, so we have x equals this one here. Very interesting here, because what we have arrived at here is actually our quadratic formula, which will be the next lesson that we're going to have, solving a quadratic equation using the quadratic formula. For now, let's have exercises completing the square. Suppose we have x squared plus 12x plus 27 equals 0. This one is in the form ax squared plus bx plus c equals 0. Completing the square method tells us that we need to isolate the constant term. The constant term here is 27. So using addition property, I will add negative 27 to both sides. So I will have x squared plus 12x equals negative 27. The next step in that process is to assure ourselves that the coefficient of the square term is 1. In this case, there's no more problem because the coefficient of x squared is 1. Hence, we are now ready to get the third term of this expression here, so it becomes a perfect square trinomial. And the formula for the third term is always 1/2 the coefficient of this linear term, which is 12. And then you square it. So we have 1/2 times 12 is 6. You square that becomes 36. This is the term that will make the left-hand side become a perfect square trinomial. So we need to add this term to the left. at the same time to the right of the equation. So we have here now x squared plus 12x plus 36 equals minus 27 plus 36. That is allowed because of addition property. Now we are now ready to write the left-hand side as a square of a binomial. That was our purpose, to have the left-hand side be written as a square binomial. That binomial is x plus 6. If you expand this, it becomes x squared plus 12x plus 36. Then, simplifying the right-hand side, negative 27 plus 36 is equal to 9. Okay, now we are in this form where we can either use extracting roots or using the absolute value. That's your choice. Let's say we extract roots when we get to this point. Extracting roots just implies us to put an arrow here. This one means that x plus 6, the square root, is equal to plus or minus square root of 9. Or simplifying this, we get x equals negative 6 plus or minus 3. And our solution set will be minus 6 plus 3 is negative 3, and the other one is negative 6 plus negative 3 will give me negative 9. These are the two values that will make the left-hand side here become 0. Let's have another example. Suppose we have here x times 2x plus 7 minus 15 equals 0. Are we ready to apply completing the square here? No, we are not, because the form that we want is the constant term should be on one side of the equation. Let's rewrite x times 2x plus 7 as 2x squared plus 7x minus 15 equals 0. The next step here is to isolate the constant term. Isolating the constant term means we are going to use addition property and use 15 on the left, 15 on the right, so that we now have 2x squared plus 7x equals 15. Are we ready to take the third term? No. The steps we enumerated ahead say this coefficient of the squared term should be equal to 1. That's for convenience. So therefore, we are going to use MPE and multiply the whole equation by the reciprocal of 2, which is 1/2, and we arrive at x squared plus 7 over 2x equals 15 over 2. Our job now is to make this expression on the left-hand side become a perfect square trinomial. And the third term that will make it a perfect square trinomial is the square of 1/2 of the coefficient of the linear term, 7 over 2, and then that. So, 1/2 of the coefficient of the linear term squared. This gives me 49 over 2 times 2 is 4, and square that is 16. Which means this one is the term that will make the left-hand side become a perfect square trinomial. Hence, adding that to both sides, 7 over 2x plus 49 over 16 equals 15 over 2 plus 49 over 16. By the method of obtaining the third term like that, we are assured that the left-hand side is a perfect square trinomial, which I can now write as a square of a binomial. Where will that binomial come from? It will be the square root of this square term here and the square root of this square term here, which is actually 7 over 4. If you try to expand this, the square of this is this, the square of that is that, and the middle term is twice the product of these terms here. So, x times 7 over 4 times 2 will give me 7 over 2x. So, these are the correct factors of that perfect square trinomial. Simultaneously, we can add the right hand side and the LCD 16. 16 divided by 2 is 8. 15 times 8 is 120. And then 16 divided by 16 is 1 plus times 49 is 49. Simplifying that, I get 169 over 16. Now I have x plus 7 over 4 squared equals 169 over 16. Notice that we can now apply either extracting roots or definition of absolute value to solve for the value of x. Okay, I have here x plus 7 over 4 squared equals 169 over 16. What if we want to apply absolute value definition here instead of extracting roots? What I will do is just to introduce the square root symbol here, and then I can now rewrite this in absolute value form by the definition. So I can now say x plus 7 over 4 absolute value equals square root of 169 is actually 13 and square root of 16 is a 4. So we have this absolute value equation where we can apply our absolute value theorem. The theorem just says that this implies x plus 7 over 4 equals plus or minus 13 over 4. Solving for x, we get 7 over 4 plus or minus 13 over 4. Okay, let's see. The first fraction will be negative 7 over 4 plus 13 over 4. 13 minus 7 is 6. So that will be 6 over 4. The next one, minus 7 over 4 plus minus 13 over 4 gives me negative 20 over 4. Or, reducing this, we get 3 over 2 and negative 5. This is the solution to the given equation. 2x squared plus 7x minus 15 equals 0. Let's have another example. Suppose we have 2x squared plus 10x equals negative 50. Here, the constant term is already on the other side. Instead of completing the square here now, we need to have this coefficient equal to 1. You guessed it, we will apply MPE by 1/2. So we will come up with x squared plus 5x equals negative 25. And on the left hand side, our third term will be 1/2 times the coefficient of the linear term, square that, we get 25 over 4. We add this third term to both sides of the equation to obtain this form. We are allowed to do this because of addition property. And from that formula, we are assured that the left-hand side is now a perfect square trinomial, which I can write as a square of a binomial. This is our goal, to have the left-hand side become a binomial square. And where do we get the binomial? The square root of x squared is x. The square root of 25 over 4 is 5 over 2. And simultaneously, we will add the right hand side. Okay, so 4 divided by 1 is 4 times 25 is negative 100. 4 divided by 4 is 1 plus 25 is plus 25. Okay, simplifying this, we get negative 75 over 4. Notice that this squared term is equated to a negative number, which means we don't have real square roots for this x plus 5 over 2. Instead, we have an imaginary root. Okay? So, taking the square root will give me x plus 5 over 2 equals plus or minus square root of negative 75 over 4. Now, I can write this as plus or minus square root of 75 times negative 1 all over square root of 4 by our laws of radicals. Hence, I can write this now as x equals negative 5 over 2 plus or minus. Remember, this negative 1 is actually I squared inside an even index. So the square root of I squared, we now have an I there, and we are left with square root of 75 inside. And the denominator gives us a 2. But notice that this radicand here can still be simplified. I can express 75 as 25 times 3. So that 25 is a perfect square, so that can go out, giving my new x value as negative 5 over 2 plus or minus square root of 25 is 5, and I will get a 5i there now, and I'm left with square root of 3 all over 2. Or, writing them in one fraction form, I get negative 5 plus or minus 5i times square root of 3. These are complex roots of this equation. In other words, there are no real numbers that will make the left-hand side here equal to negative 25. They appear to be imaginary numbers. Let's have another example. Suppose we have quantity 1 minus 2x times quantity x minus 3 is equal to 5. This also gives us a quadratic equation because we have a square term. But are we ready to solve this by completing the square? No. We need to expand this. So how do we do that? You can do distributive multiplication. 1 times x is x. And this one here, 1 times negative 3 is negative 3. And below, I will have here minus 2x squared. And this one is plus 6x equals 5. Combining like terms, I will have here negative 2x squared. X and 6x will give me 7x. And the minus 3, I'm going to bring it to the other side. It becomes a plus 3, so I will get an 8 on the other side already. Now, it's very inconvenient to have a coefficient of the squared term not equal to 1. So what do we do here? We are going to multiply everything by negative 1/2. Multiplying everything by negative 1/2 will give me x squared negative 7 over 2x equals negative 1/2 and 8 is negative 4. Here, my third term is 1/2 of that numerical coefficient, 7 over 2, and then squared. You have to memorize this formula. So, this is negative 7 over 4, square that becomes 49 over 16. This is the term that we need to make the left-hand side here become a perfect square trinomial. So, again, by APE, I'm going to add that same number to both sides of the equation. And now, I can express this as x minus 7 over 4 squared. And simplifying this, I get minus 64. This is minus 64 plus 49. And this gives me another negative number. 14 minus 9 is 5. Minus 5 and 4 is minus 1. So I have a minus 15 here, and then I have a 16 here. Okay? Extracting roots, I will now get x minus 7 over 4 equals plus or minus square root of negative 15 over square root of 16. And I can simplify this again. Remember that this is an even exponent. The negative there becomes an I squared. So I will have plus or minus I times square root of 15 all over square root of 16 is 4. Hence, my solution to this will be 7 over 4 plus or minus I times square root of 15 over 4, or combining them to a single fraction will give me 7 plus or minus I square root of 15 to be the solution set of that number. I would like for the last portion of this discussion, I'll just give one example where we can have an alternative solution for completing the square. Suppose we have here x squared minus 5x minus 6 equals 0. From this form, I can identify the value of my a to be equal to 1 and b to be equal to negative 5. Okay. The alternative way of completing the square will be to do the following. Step number 1, MPE by 4a, and step number 2 will be APE by b squared. So these are the steps that we have to follow. Okay? So let's say, what is my 4a here? It will be 4 times 1 equals 4. What is my b squared here? It will be minus 5 squared equals 25. So we need to have only 4 and 25 in that equation. Okay, so we can now write this as x squared minus 5x equals 6. Now, the first step here is MPE by 4a. Okay, by 4a. But 4a is actually equal to 4. So we will multiply this by 4. And we get 4x squared minus 20x equals 4 times 6 is 24. And then the next step is APE by b squared. B squared here is actually 25 as we computed. So I will now say 4x squared minus 20x plus 25 equals 24 plus 25. These two steps will assure me that the left-hand side will become a perfect square trinomial. Okay, so I can now write the left-hand side as the square root of 4x squared is 2x and the square root of 25 is 5. The sign between these two terms should be the sign of the middle term here. That's a negative. And then I will have that square there and I will add this. I will get 49. Now, if you want to check whether this one is the same as this, you just have to square 2x. You get 4x squared. Square negative 5, you get a plus 25. And the middle term will give you negative 20. So we got the correct factors here. Okay, from absolute value definition or extracting roots, we can now have 2x minus 5 equals plus or minus square root of 49 or plus or minus 7. And this gives us 2x equals 5 plus or minus 7, x equals 5 plus or minus 7 all over 2. So my solution here will be 5 plus 7 is 12 divided by 2 is 6. 5 minus 7 is negative 2 divided by 2 is negative 1. So this is an alternative way of doing solution by completing the square. I hope you were able to follow my discussion. Thank you.